As a software developer, building a robust database is fundamental to any application's success. Let's explore the three essential components. The first step is understanding database objects. These include tables, views, indexes, stored procedures, and triggers. Each object serves a unique purpose in organizing, accessing, and managing your data efficiently. Tables are the backbone of any database. They store your data in rows and columns, much like a spreadsheet. When designing tables, choose clear, descriptive names and define appropriate data types for each column. Indexes speed up data retrieval. By creating indexes on frequently searched columns, you can dramatically improve query performance. However, too many indexes can slow down data insertion and updates, so use them wisely. Relationships define how tables connect. Use primary keys to uniquely identify records and foreign keys to link related tables. This enforces data integrity and prevents orphaned records. First, create database objects. When creating tables, always define primary keys. Avoid using natural keys like email addresses or phone numbers, as these can change. Instead, use surrogate keys such as auto-incremented integers or UUIDs. Views are virtual tables that present data in a specific format. Use views to simplify complex queries, enforce security, or provide custom data perspectives for different users. Design tables, indexes, and relationships that form your data model's foundation. Triggers and stored procedures automate tasks. Triggers respond to data changes, while stored procedures encapsulate business logic for reuse and consistency. A well-designed schema is essential. Normalize your data to reduce redundancy and improve consistency, but avoid over-normalization, which can make queries complex and slow. Common mistake: neglecting to document your schema. Always maintain up-to-date documentation so your team can understand and maintain the database effectively. Next, manipulate data in your DBMs. Data manipulation involves inserting, updating, and deleting records. Use SQL statements like insert, update, and delete to manage your data. Always validate input to prevent errors and security vulnerabilities. Use transactions to group related operations. Transactions ensure that either all changes succeed or none do, maintaining data integrity. Remember the ACID properties: atomicity, consistency, isolation, and durability. Stored procedures help you encapsulate complex logic and reuse code. They also improve security by restricting direct access to tables. Execute queries, transactions, and stored procedures to manage information flow. Optimize your queries for performance. Use explain plans to analyze how your database executes queries and add indexes where necessary. Avoid select in production code. Always specify the columns you need. Regularly back up your database. Test your backups to ensure you can recover data in case of failure. Automate backup schedules and store copies in secure, off-site locations. Finally, define data security schemes. Security is critical. Implement user authentication and role-based access control to restrict who can view or modify data. Use strong passwords and multi-factor authentication where possible. Encrypt sensitive data both at rest and in transit. Use industry-standard encryption algorithms and keep your encryption keys secure and separate from your data. Implement user permissions, encryption, and access controls. Regularly audit your database for suspicious activity. Set up alerts for unauthorized access attempts and review logs to detect potential breaches early. Apply the principle of least privilege. Only grant users the minimum permissions they need to perform their tasks. This reduces the risk of accidental or malicious data loss. Key technical vocabulary for further study: database management system, SQL, schema, normalization, indexing, transactions, encryption, and access control lists. Performance tuning is an ongoing process. Monitor your database with profiling tools, identify slow queries, and optimize them. Partition large tables and archive old data to keep your database responsive. In real-world scenarios, always test your database under realistic workloads. Use sample data and simulate concurrent users to uncover bottlenecks before going live. To summarize, successful database development requires careful planning, attention to detail, and ongoing maintenance. Follow best practices, stay updated with new technologies, and always prioritize data integrity and security. For further learning, explore resources on advanced SQL, NoSQL databases, cloud database services, and emerging trends like database automation and AI-driven optimization.